In other words, we're going to start exploring one of our methods that we can use to take the antiderivative or the integral of some function that we may not necessarily see what the original function was right away. In other words, if we had something like the integral of 2x dx, we know that the antiderivative very quickly is just going to be x squared. Where we use substitution is when we don't necessarily see that direct connection, and usually it means that there's something that had the chain rule applied to it, and we can use this U-Substitution in order to help us simplify the integral, and then we can substitute back at the end, and we can take a more complicated antiderivative than we necessarily otherwise would be able to. So the first part here, we're going to talk about what is the difference between the integral of f of u with respect to u versus the integral of f of u with respect to x. And this dummy variable here, the du or the dx, actually changes the overall value of the integral, or the overall result. So these are going to be two very, very different answers. So let's kind of go through an example of what this would mean. So to start, let's just say that we had some function where f of x is going to equal, we'll do x cubed plus 1. And we're going to say that we're going to let this value u, whatever u is, it's going to equal x squared. Okay, and so we're going to do three examples here. The first one we'll do is the very, very simple. We'll take the integral of f of x with respect to x. So that's just going to be very simple. The antiderivative of x cubed plus 1, and again, it's just with respect to x. So in this case here, we can just say, all right, well, we know the antiderivative of x to the third is going to be x to the fourth over 4 by the application of the power rule, plus x, right, the antiderivative of 1, and then plus our constant of integration plus c. Okay, so this is what we get if we just take the antiderivative of f of x with respect to x. Nothing there changes. Okay, if we decide to take the integral of f of u with respect to u, it's going to be very, very similar. Okay, well, if we have f of u, that really means that we just have the integral, and it's just going to be u cubed plus 1. And that really just comes out to, oops, I should have the du there. Don't forget my dummy variable. So let me erase that. And that's just going to be basically the same thing, but in terms of u. So that comes out to be u to the fourth over 4 plus u plus c. Okay, and this is really what we would leave it as, but in order to show that this here is actually a different value than this here, remember, u equaled x squared. So if I plug in that x squared for u, this really would equal x to the 8th over 4 plus x squared plus c. Okay, so we can see that these are two very, very different results. That's because, well, the value of u was actually equal to x squared. All right. If we do a third example, where we take the integral of f of u, but this time we want to take it with respect to x. Okay, well, that means that we're taking the antiderivative still of u cubed plus 1, but again, it's the antiderivative with respect to x. So really, we need this to be in terms of x before we take that antiderivative. So that means that we're going to get the antiderivative of x to the 6th plus 1. And now we're taking that antiderivative with respect to x. That ends up giving us x to the 7th over 7 plus x plus c. And so again, you can see that all three cases here give us a slightly different answer. In the first one, we take the antiderivative with respect to x. We just go ahead and take this function, x cubed plus 1, take the antiderivative, put the c on the end, we're all set. The second one was very similar. We just used a u substitution, but u equaled x squared. So even though this here could have been our final answer, just to show that this is actually different than our original, we put it back in terms of x. So you can see that relationship there. And then lastly, for the third one, we want to take the antiderivative of u of f of u rather with respect to x, well, that meant that we needed to have it in terms of x before we integrate. And that gives us the x to the 7th over 7 plus x plus c. So the lesson here is that this dummy variable at the end, the dx or the du, tells you a lot about what you're doing with that integral in terms of with what variable are you taking the antiderivative with respect to, right? In all three cases, we don't see, the du or the dx, in our final answer. It's just telling us along the way what variable are we treating as our independent variable. Okay, so let's go ahead and take a closer look then at some of this U-substitution. All right, so here we have two examples of integrals. Okay, these are both going to require some U-substitution. So again, the U-substitution is used when we believe that there is some application of a chain rule involved and we don't necessarily clearly see it right away. So in this case here, I'm usually going to have U equal my innermost function. So in this case, I'm going to say U is equal to 7x minus 2. Okay, and that's going to take place of this right here. And because I know this, I know that du is going to equal 7 dx. Okay, so what I want to be able to do is I want to be able to somehow turn this, and so that I have a du instead of a dx and a u instead of an x. Okay, so the first thing I'm always going to do, if I have a constant right here like this 28, I'm going to pull that out first because that's just going to kind of it's going to muck things up a little bit as we try to go through this. So I'm going to make this 28 times the integral, and this was 7x minus 2 to the third power dx. Okay, so clearly I see that right here I can replace this 7x minus 2 with a u substitution right there. And I have a dx right here, which I have here. What I'm missing is that 7. So if I want to include a du here, I really need to have a 7 somewhere inside this integral. So if I put a 7 on the inside, I need to be able to balance that out with a 1/7 on the outside. Okay, so now what we end up getting is this 1/7 times 28 gives us 4 times the antiderivative of, and this is going to be u cubed du. Okay, and this becomes very, very easy to integrate, right? It's going to be 4 times, this is just the power rule now, so we're going to get u to the 4th over 4, okay? And then it's plus c at the end, and these 4's are going to cancel, so we're just going to end up with u to the 4th plus c, and remember, we know that u was actually equal to 7x minus 2, so this whole thing comes out just to be 7x minus 2 to the 4th power plus c. And that would be our equivalent to this integral right here. All right. So again, we're just using that u substitution to kind of simplify it for us so that when we apply something like the power rule, it's a very, very simple application. All right. Let's take a look at this second example over here, this cotangent of 7x. All right. And this one's kind of a little bit unique. What we're going to do here is before I take any kind of derivative or anything like that, I'm just going to rewrite the cotangent as cosine over sine. So let's just make this sine of 7x over the cosine of 7x dx. Okay, and really the reason for that is now when I try to do my, oops, that's not correct, it should be cosine over sine like we just said a minute ago. So that should be cosine 7x over the sine of 7x. Okay, and so really the purpose there is to make it a little bit easier on ourselves when we go ahead and do this u substitution. If we just plug in for 7x, we'd have to know what the antiderivative of the cotangent is, which I don't know that everybody necessarily knows that right off the top of their head, but if we're dealing with sines and cosines, usually those are a lot easier to deal with. So let's go ahead and make u equal to our sine x. And again, the reason I'm making u the sine x is that I know that du, or sine 7x rather, I know that du is going to equal 7 cosine 7x dx. Okay, so I know that the derivative of the sine is the cosine, right? And so therefore, I have all my pieces here accounted for already. If I made u equal to the cosine, then I would end up with a negative sign on top, but I have the sign on the bottom, and it would kind of come out, again, it would be more difficult than I needed it to be. So if we do it this way, right, we want to be able to plug in right here, so we're going to have to include a 7 with that dx, right, in order to get rid of it. So that means I need to have this 1/7 out in front. So now as we go ahead and do this, we get 1/7 times the integral, and it's going to be du over u. All right, and then this right here, we already know that's going to just be the natural log, so I'm going to get 1/7 times the natural log of the absolute value of u plus c. And since I know that u is actually equal to the sine of 7x, we get 1/7 times the natural log of the absolute value of the sine of 7x plus our constant of integration plus c. Okay, and so this right here would actually end up being the integral of cotangent of 7x. So I hope these examples kind of help. Again, whenever you use the U-substitution, you're looking for something that you first can easily take the derivative of. Second, you want it to be one of the innermost functions. And thirdly, when you take the derivative of it, it's great if some piece of that derivative shows up in the integral you already have. So for example, in this example here, when we tried to find what to make u equal, we chose the innermost piece, right, the 7x minus 2, and then when we take that derivative, it came out rather easy. Over here, there wasn't necessarily an innermost piece. That 7x may not have necessarily helped us unless we knew what the antiderivative of the cotangent was off the top of our head. But when we get to this point here where we have cosine over sine, again, the reason we're choosing to make the sine equal to u and not the cosine is that when we take the derivative of the sine, we get cosine. So again, I see a piece of that derivative already in the integral, and that's kind of how I knew to go that route. All right. So I hope these examples helped, and I will see you in the next video.